Resolution of racemic mixtures. What is resolution? Resolution is a process of separating the racemic mixture into its active compounds, that is enantiomers. Then what is the need for resolution of racemic mixture? So these are some examples. First one is cetirizine. Cetirizine is a drug and it is used for sedation. So it exists as two form, R form and S form. Cetirizine is an optically active compound. So the levocetirizine has been found to be less sedating than cetirizine, than the dextroisomer. Then second one is levodopa, that is it exists as L-dopa and D-dopa. Levodopa is used for the treatment of Parkinson's disease, whereas the D form causes serious side effects. So it is necessary to separate the racemic mixture into enantiomers, its active compounds. So these are the 5 methods for the separation of racemic mixture. First one is the mechanical separation. Second one is crystallization by inoculation. Third one is the biochemical method. Fourth one is the chemical method. And fifth one is the kinetic method. First one is mechanical separation. So this method is used to resolve the racemic mixture of definite size and shape. The crystals can be separated by hand picking or by forceps or by lens. Pasteur applied this method for the separation of racemic sodium ammonium tartarate. And this method is time consuming and every compound cannot be crystallized at room temperature. The next method is crystallization by inoculation, that is seeding. This technique is used for the separation of racemic mixture, and in this technique a supersaturated solution of the racemic mixture is inoculated with the crystals of any one of the enantiomers or any isomorphous crystal of an optically active compound. Example, sodium ammonium tartarate is preferentially crystallized by seeding the racemic solution with an optically active compound minus asparagine. So this is the example. And third one is biochemical method. In this method, certain microorganisms resolve the racemic mixture by destroying any one of the enantiomers. Example, penicillium glaucum resolve plus or minus tartaric acid. Plus or minus tartaric acid is a racemic mixture. It consumes plus tartaric acid for its growth and leaving the minus tartaric acid unused. So we can easily separate the plus tartaric acid and minus tartaric acid from plus or minus tartaric acid. This method leads to the destruction of one of the enantiomers, and it is sometimes difficult to find a specific microorganism for racemic product. Then fourth one is the chemical method. This is the general method for the separation of racemic mixture. The principle involved in this method is the conversion of a racemic mixture into diastereomers with the help of an optically active compound. Then the diastereomers are separated into the respective enantiomers. Example, separation of plus or minus tartaric acid using minus Q9. Minus Q9 is also optically active. Plus or minus tartaric acid is a racemic mixture. When the plus or minus tartaric acid is treated with the minus Q9, it is converted into diastereomers. That is minus Q9 plus tartaric acid and minus Q9 minus tartrate. Then these diastereomers are separated by fractional crystallization. And finally, minus Q9 plus tartarate is separated into plus tartaric acid and minus Q9. Minus Q9 minus tartrate is separated into minus tartaric acid and minus Q9. And this is the general method for the separation of racemic mixture. The last one is the kinetic method. This method is based on the difference in the rate of reaction of enantiomers with that of optically active compound. Example, minus menthol reacts faster with the plus mantelic acid than that of minus mantelic acid. So this is mantelic acid. It also exists as plus form and minus form. If the reaction is stopped before completion, on hydrolysis, minus menthol plus mantellate dominates. And from this, it is easy to separate the plus mantelic acid. So this is the fifth method for the separation of racemic mixtures. Thank you. Hope you understood the methods for the separation of racemic mixtures. Thank you.